Okay, hello guys. Today our topic is about atom and electricity. Okay, so we are basically focusing on what is atom formula and what is the principle of it. Okay, and also we are just discussing some properties like alpha decay and also for like the half-life and many other kind of like atoms and electricity part knowledges. Okay, so first part we are learning about radioactive decay. Okay, so let's move to this part. Okay. So here you can find there's a system, or maybe you can find many particles or many atoms inside this. There are 40 million undecayed nuclei. Okay, so they're all painted as the purple color, right? And you can find first is at 0 day, and maybe after 8 days, you can find a half of the undecayed nuclear turns into decayed nuclear. Okay, you can find maybe there are 40 like balls represented for 40 million. And maybe we cannot draw all the 40 million atoms right here, right? Okay, so we can just using one ball to represent for 1 million. Okay. So you'll find that 20 million or like 20 balls in the figure just turn into light purple, right? You can find there's color change. So we can find after 8 days, there are 20 million, or we can say a half of the nucleus decayed, right? So now we give a new name that is called half-life or half-time. Okay. So for an unstable like atoms, they combine together and you can say, oh, maybe right here it has to decay, and after half-life of these atoms, it just turned into a half like numbers of this. Okay. And also very interesting that there's a like a phenomenon. And after half-life, and you can find it's from 40 million to 20 million. And after another half-life, it's from 20 million to 10 million. Okay. So it's a constant time taken for a total system. Okay. So after another half-life, you can find here there are only 10 purple balls in the figure. And maybe after other 30 balls represented for 30 million like nucleus are decayed. Okay. So after another half-life, and you'll find that maybe after 8 days, and only 5 million undecayed nucleus still in the system. Okay, so here is for the rate of decay and what is half-life meaning. And having each half-life, that means total or like the original atoms, the number of it just turns into a half. Okay, this is what half-life meaning for you. So we can draw a graph for the half-life. So like maybe in sorry, and I will use this pencil, and here you can find there on the y-axis it means total number of the nucleus, or you can also this means like radioactivity. Okay, and the x-axis means the time taken. Okay, so maybe after eight like days, and here our atom just from 40 million to like 20 million, right? And after another 8 days, it just from 20 million to 10 million, right? And after another 8 days, maybe here 16 and maybe here 24, and it just turned into like 5 million left in the system, right? So we can say this is a number of nucleus or number of the like original nucleus with a time taken graph. Okay, here is it. And you can find each of the atoms or each of the isotopes, they have different half-life. Okay, so maybe you can find in the first column and first like rows. Maybe in the first row you can find there are sorry boron 12, and you can find it half-life is very small, 0.02 second. Okay, so that means boron is very unstable. So whenever the environment is, every time, every period after 0.02 seconds, it just changes into another atom. Okay. And you will find that maybe if an atom is very big, you can find there is uranium 235 and uranium 238. You can find, oh, maybe here the half-life is very quite big time period, right? Okay, so this is for different half-life. And remember that half-life just depends on what the atoms are, okay? And this doesn't depend on like the temperature, like other maybe for the pressure and other kind of physical quantities, okay? It only depends on what is the atom is, okay? So like if you change this other environmental coefficient that doesn't have any effect or influence in the half-life, okay? So this is for half-life. I think it's very important for you to first understand it, okay? And here you can find yours like an activity and half-life graph we have said before and we have drawn before, right? And you can find the y-axis, you can mean the number of the like decayed nucleus, or sorry, number of undecayed nucleus or activity. And the x-axis means the time taken. So it's just like in graph when you're learning IGCSE mathematics, you will learn that here is y equals to 1 over x, right? This is for this graph. Okay, so here it is. I think it's not very difficult for you, right? Okay, y equals to 1 over x. Okay, so it's just like, but remember that here is just from x-axis because there is an initial for a time taken, and after half-life, the value just becomes a half. Okay, so in some IGCSE past papers, you'll find some questions like it gives you the Y label and you want to find the half-life. So you can first find the initial value and then find its half value and draw on the uh, like the coordinate, and you'll find that, oh, maybe here the difference from this point x-axis to 0, it means half-life. Okay, I think it's not very difficult for you. Okay, this for this. Okay, and you can find we can draw the graph like here. Like after 8 days, the total numbers of this is from 40 to 20, and maybe also from 20 to 10, and also from 10 to 5. Okay, but remember that this is a statistic value on the graph. Like here you can find maybe like not all the time it follows very exactly at this number, like maybe 40. Maybe for this period, or maybe here is 20.5. Okay, there's a little bit a difference between the expectation value. Okay, so here it is. You can find it just like a overfit or like lines between the points. Okay, it's just a statics. Okay, so statistics is very important, right? When you learn the mathematics, you will learn that. Okay, so also in some physics, we're also using the statistics to like discussing of this. Okay. So maybe in the future, you will learn about quantum mechanics or other kind of physical knowledges. They're very high advanced, and they're also based on the statistics. Okay, but in fact, in our IGCSE test, we don't need to understand or we don't need to know that there is a statistic value. But right here, you will know that, oh, maybe we draw a like best fit graph, best fit curve in this point. Okay. Okay, so trying to solve the problem, please. Okay. Okay, so I guess this problem is not very difficult for you, right? And first in this graph, you can find there is a 4,000 decay rate per second, right? That means at the very first beginning, here we have a 4,000 radioactivity, right? So if we want to find half-life, first we have to find when the radioactivity or like the decay rate becomes to a half and the time period, right? So from 4,000, it becomes a half is 2,000, right? So here we can find this point, and this point represents for 2 days, right? So maybe we can say from 0 day to the second day, it takes 2 days in the time period. Okay. So you have said, oh, here maybe 2 days is for the half-life. Okay. So maybe said it after 8 days, what will the decay rate becomes, right? So first, from 4,000 to 2,000, this like goes through 2 days. And for another 2 days, we have to go through 2,000 to 1,000, right? Like here. Okay. And after another 2 days, we have to go through from 1,000 to 500, right? So maybe here it is. This is 500. And after the last 2 days, we have to just turn the 500 to 250, like here. Okay. So here we can say, oh, this is 250. Okay. So finally, we are choosing C as our final answer. So every passing through a half-life or like a half time, the total decay rate just turns in half. Okay. So that's it for today's our lesson. See you next time. Bye.